So grade 11s, are you ready for the last month of grade 10 math in 10 minutes, maybe 12? Okay, we're going to review the key features of the different forms of quadratics. So the first one that I have here is in what we call factored form. It has been written as a multiplication where you can see two separate brackets. Whoops, factored form. Let's just put another set of quotes here, shall we? Let's have a look at that function for a minute on Desmos. The nice thing about Desmos is that it graphs quickly and it shows us those key features right off. So I can see from my graph that I have these key features. We're going to highlight all of them and make a note of them. So I have x-intercepts of 3 and -1, a y-intercept of -6, and a vertex of 1 minus 8. So let's make a list of that. I have x-intercepts of 3, -1, a y-intercept of -6, and a vertex of 1, -8. So those are all my key features that I cheated with. And so what I'm asking you today is, if just given the equation, what would we know? So in factored form, I can see my x-intercepts. Always, when things are in brackets, that sign is opposite to what you might expect. So I've got an x-intercept of +3 and -1 directly from that equation. What else do we know? We know that the step pattern on that parabola should be opening up, and it should be a vertical stretch factor 2. Let's look at the graph for a moment and just make sure that it's following that step pattern that we expected. So if you look at the vertex, I can go over 1, up 2, and that is my step pattern, twice as high as it normally is, so that a value is as expected. So those are the things that I could obtain directly from the equation. And my second question is going to be, what can we find? Can I use this equation to find the other two pieces, my y-intercept and my vertex? Well, for the y-intercept, we notice that the x value is 0. So if I were able to substitute x equals 0 into that equation, would I get -6? So a little bit of arithmetic. If y equals 2 times 0 subtract 3 and 0 plus 1, I have 2 times -3 times 1. 2 times -3 times 1 is -6. So I can find the y-intercept. The vertex is a little bit harder. We are going to spend a bit of time with that in the next few days, but the vertex is not immediately obvious from our equation. But if we look at the graph again, we can see that the vertex lies exactly in the middle of the two x-intercepts. So if I know my two x-intercepts are 3 and -1, I would know that my vertex would have to lie on the x value of 1. How could I obtain the matching y value? We would substitute. So let's write a note about that. So I can find that vertex. It's just going to take me a little bit of work. To find the x value of the vertex, it would be the average of the x-intercepts. So the x value of the vertex would be 3 plus -1 divided by 2 to find an average. 3 plus -1 is 2. 2 divided by 2 is 1. So yes, I can find the x value. How would I go from there to find the matching y value of the vertex? Like we did for the y-intercept, we can substitute x equals 1 into the equation. So for my equation, y equals 2, I'm substituting a 1. I would have 2 times -2 times 2 is -8. So I can find that piece as well. Let's look at a different form. y equals 2, x minus 1 squared minus 8 is in vertex form, so you'll never guess what it tells us. This is the one we started with in 2D, and it's the one we like better in 3U because it uses, I don't know, I'm so quotey today. Anyway, it uses transformations of our parent function y equals x squared. So from unit 1 we have a vertical stretch factor 2. We have a horizontal shift 1 to the right and a vertical shift down 8. So we could graph this one a whole lot more quickly because we understand the transformations. But as far as key features go, what do we know? Well, we know that this one also has a vertical stretch factor 2. We know that this one also opens up. And because we know the translations left, right, up, down, we know the vertex. It is 1 to the right, down 8. That's weird. It has the same vertex as the last one. Odd. Anywho, my second question is, what can we find? Can we find the y-intercept? Can we find the x-intercepts? Okay. Last time when we were looking for the y-intercept from an equation, we said, gosh, a y-intercept always has an x value of 0. So if I substitute x equals 0 into the equation, I should be able to find the y-intercept. This one is a tad uglier, but not a lot. Y equals 2, 0 minus 1 squared minus 8. Here we go. I have 2 times negative 1 squared. Negative 1 squared is positive 1. 2 times 1, order of operations. 2 times 1 is 2. 2 subtract 8 is negative 6. So we can find the y-intercept by substituting x equals 0 just like last time. And also, the y-intercept is the same. Crazy. The last one, can we find the x-intercepts? Let's look at Desmos for a second. Here is our new quadratic equation, and I can see the y-intercept that I just discovered, the vertex, as it should be from the equation, and my two x-intercepts are 3 and negative 1. So this is the identical parabola. How can I get to those values of 3 and negative 1 from that crazy equation? Well, it is doable, but it's a little bit ugly. And again, we're going to spend a bit more time thinking about x-intercepts later on this week, but to find x-intercepts, I know that my y value is 0 for x-intercepts. So it is possible to set my equation equal to 0 and solve for x. Okay, so if y is 0, I want to know when this is true. Okay, so to solve an equation, we do the reverse order of operations. I'm going to add 8 to both sides. I'm going to divide both sides by 2. And this is where we take a bit of care. If you are going to do the opposite of squaring, we square root. But if you impose a square root on things, you need to consider the positive and the negative square root. The last thing I need to consider is getting rid of subtract 1. And again, we're going to spend more time with this. A little later, we're just doing an overview of all the things we can find. So very last statement. One of my x-intercepts is 1 plus 2. The other x-intercept is 1 subtract 2. So we were able to find both of those x-intercepts. The last function that we're going to look at today is in standard form. And we'll take a look for a moment at Desmos. So this is a shock, but it is the very same parabola that we've been looking at in the other two. It has the same key features. We're going to list what we can see obviously from the equation and determine what we can find. So from this equation in standard form, we can see that it opens up, that it has a vertical stretch factor 2, And we can see that the y-intercept is 0, -6. This is a quick substitution. If you put zeros in for x, this disappears, and we're left with -6. So that c value, when we wrote it out in standard form, y equals ax squared plus bx plus c, the c value is always the y-intercept. So those are the three easy things to find from this equation. But what things can we find? Can I find the x-intercepts and the vertex? So we have some work to do. To find the x-intercepts, we have two choices. Number one is to factor. The second choice is quadratic formula. We're going to be looking at both of those later on this week. It is findable, but it takes a little bit of algebra to do that. Lastly, the vertex. Can we get the vertex from the equation? We have two options as well for finding the vertex. The first one is completing the square, which we have looked at. The second option is once you have the x-intercepts, you can average them like we did on the first slide. So once you have these, we can average the x-intercepts and substitute that value in and find the matching y value for the vertex. So everything is findable, but some things are more obvious depending on the form of the quadratic that you find. We'll work on an activity where you're gleaning all of that information.